Hey students, this video is all about geometric proofs, lesson 3.04. So these are my three main tips for writing two-column proofs, and this is geared mostly for a class where you have to fill in the blank for a proof. And so I'd recommend doing it on scratch paper first, always. On the left side of your proof is going to be the statements, on the right side is the reasons. And you're also going to want to start with what's given and end with what you're trying to prove. And I'll reference these tips when we go through some examples here. So here's a typical problem that you might see. You're given some information and it's telling you what you're trying to prove. And what you're basically doing is you have your statements, various steps on the left-hand side. And then on the right-hand side is an explanation as to why you got to that step. And so I have here all of my reasons are at the top. I'm just going to spread these out. And I'll give you a moment to try this on your own, but I'm first going to try this on scratch paper as I recommended for the first tip. So the given information is that angle AOC and COB are complementary. So AOC is in the diagram right here, COB is the lower angle, and it says they're complementary. We can actually see that in the diagram. If you recall, complementary means they add up to 90 degrees. So that might be something you just kind of write down in your scratch work. And then it also says that the measure of AOC is 60 degrees. So that's this angle right here. Maybe it's helpful to kind of draw the diagram in your scratch work since these problems will be on a computer. So that full angle is 90. Use a different color to show that this smaller angle is 60. And we're trying to prove that COB is equal to 30. So COB is the smaller angle right here. And we're trying to prove eventually that this is equal to 30. And since the two angles add up to 90 degrees, we can kind of, conclude that just adding those two angles together is going to show that they're complementary. So COB has to be 30. So let's try to put this into a proof now. So as I gave in the tips, you want to always start with what's given and end with what you're trying to prove. So the two statements at the top here, we have AOC and COB are complementary angles. The reason that's true is because they gave that to us. So that's kind of a nice gimme one that you can usually put in there. And then I did say the top two statements, but actually it's this second statement here was not given. It says AOC and COB is equal to 90. This little m in front means the measure of those angles. You can kind of ignore it. It's just saying what those angles add up to being 90. That's actually not given in this statement here. So we want to look at our options here and say, okay, why can I get to step 2 from the step above it? Usually it's the step above it. And it's saying that AOC and COB, when I add them together, equals 90. Well, kind of referencing this statement above, it says that those two are complementary. And so that means I'm going to say that's the definition of complementary, that those two would add up to 90. Okay, so how did we get to step 3? What is my why? Why is AOC equal to 60? Well, that was given in our problem here. And so that's a scenario where given isn't always going to be at the top, but we're still kind of starting with what's given. And then I want to look at this next equation here. We only have two options left, so that should be easy to, or easier, I guess, to decide which one would go next. But let's take a look. So how did they get this equation right here? They got 60 plus COB is equal to 90. Well, they're kind of grabbing from these two steps above it. They're replacing AOC with the number 60 because we said that in step 3, that AOC is equal to 60. So which of these options is the reason why we got this equation here? And that's, we were using substitution. We're substituting 60 for angle AOC. And then there's only one left, but how is the last one the subtraction property of equality? Well, they really just subtracted 60 from both sides to solve this equation to get that COB is 90 minus 60, which equals 30. And that's a basic start to writing a two-column proof. Let's look at the next one. So this one, I have some statements missing and some reasons also missing. So I have my properties up here, or well, statements and reasons. My pieces are kind of in white, so you don't know which way it's going to go. So let's try to do this on scratch paper. So it says here that triangle ABC has measure of angle A to be 38, B is X, and C is X plus 2. That's how it's listed in the diagram there. And we want to prove that X is equal to 70. Okay, so if you're not really sure where to start with a problem like this one, you can always reference your proof. So it says that they started with the given information, which is basically in the diagram, and then they went on to say that the measure of angle A plus measure of angle B plus measure of angle C equals 180. Okay, so if you recall, that is a property of triangles, that all of their measures are going to add up to 180. We can probably actually drag this one down here to get that to start there. And then what did they do in their next step? Well, it looks like they may have taken each of those angles. We can even do it in our scratch work. They basically did A plus B plus C equals 180. In fact, I'd always recommend using that if you ever dealing with triangles and angles. Keep that little property in your back pocket is what you're probably going to use. So A is 38, B is X, C is X plus 2. And they did some substitution in that second step there. And so from here, we just want to combine like terms to make things more simple. So I can combine 38 and 2 to get 40. And then X plus X is 2X, equaling 180. And then we're just solving from here. So subtract 40 from both sides. Get 2x equals 140, divide by 2, and x is going to be 140 divided by 2, which is 70. And that's good because the nice thing about these is they tell you what your answer is supposed to be. So let's look at the proof. So how did they get this step here? Well, you might recall from our scratch work that we took the A plus B plus C equal 180, and we had to replace those values in there. So that's going to be substitution. And the nice thing about statements is there's usually equations involved with them. So I can kind of conclude that these two are going to be on my statement side. And then my one last reason is probably going to be at the end in this missing spot here. But which of these is going to come first? And this is where your scratch work might come in handy. Well, it looks like they have this 40 plus 2x equals 180 written right there. And then above that, that is above the 2x equals 140. This just might be a little bit simpler to kind of do it in your own work so you don't have to try to make sense of what they're doing necessarily. And then the last step, to get to 70, we had to divide both sides by 2, as we did at the end here, dividing both sides by 2. And so we used the division property of equality. And that is it for that two-column proof. Let's do one last one where we have a quadrilateral involved. And so similarly to the last one, it tells us some information, and it looks like all of this information is given to us in the diagram, labeling those angles there with what they should be. We have to prove that x is equal to 18. So let's spread these out here. If you're not really sure where to start, it looks like they already said what was given in the top here. And then, oops, there's a little typo right there. We have the measure of A plus B plus C plus measure of angle D is equal to 360. Now, why is that true? Why do all four angles add up to 360? We'll take a look at what options we have here. And in fact, you can even kind of split this up by the ones that are probably going to end up going on potentially going on the left-hand side and the ones that are potentially going to go on the right-hand side. And I can actually see that I have more options here than what I need to put into the proof. But why do those angles add up to 360? Take a look here. Which properties might that be because of? It's because the sum of the interior angles of a quadrilateral is 360. If you didn't know that, just like how the sum of the angles of triangles is 180, there's an interesting property of quadrilaterals where they add up to 360. Okay, and let's see what they did here. So they have this equation, and it says they did the substitution property. So it looks like they just plugged in these angles in for A, B, C, and D. And then the question is, okay, so what comes after that? It says combining like terms. And this is where it might be helpful to kind of take your scratch work out. So we had all these angles added together. You don't have to necessarily include the parentheses. Should all add up to 360. And they said they combined like terms. And so 6x plus 4x plus 6x plus 4x. We have 10x here and 10x here. 10 plus 10 is 20x equals 360. And taking a look back at the proof, that's going to be this option next. And then how did they get to 18 from 20x is equal to 360? Well, they had to divide both sides by 20 to get there. 360 divided by 20, you can use a calculator if you want. That's going to give us our 18. And so we use the division property of equality. And that is a brief introduction with a few examples of how to do two-column geometric proofs.